Hello, YouTube. This is Jay Coder here, back with another stream, and today we're going to be making, starting a little app called the Tip app, and so it's going to help us to practice the working with XML layouts. We've worked with them before in previous tutorials, but this should give us a bit of a deeper dive into it. And so if you want to learn and grow in Android development, continue to watch this channel, subscribe, and without further ado, let's get started here on our lesson. So I'm going to be going over the code lab, create XML layouts for Android, and I'm going to go ahead and mute the music there. And before you begin, in this code lab, you will be building the layout for a basic tip calculator app. At the end of the code lab, you'll have a working UI for the app, but the app won't actually calculate the tip yet. Making the app work and look more professional will be the following code labs. Prerequisites: able to create and run an Android app from a template in Android Studio. What you'll learn: how to read and write XML layouts in Android, how to build the layout for a simple form to take in user text input and choices. What you'll build: the UI for a tip calculator Android app. When you need: a computer with the latest stable version of the Android Studio installed, internet connection to access the Android developer documentation. So, alright, and also I'll go ahead and post this link for so people can reference the Android developer documentation. And also let me go ahead and post this collab in the chat for everyone to follow along, as well as I'll post it later too in the description for everyone to follow along. Alright, and then I'm going to also post the Android developer documentation, developer guides for further study in the future for those who want extra study. I'm gonna post this and join the above link is to the official Android developer guides. Alright, let us go on. And then, so check out the tip calculator on Google. So here we have a tip calculator where let's see, the bill is $20 and it suggests that you tip $3 for one person. In this pathway, you'll build a simple version of a tip calculator as an Android app. Developers will often work in this way, getting a simple version of the app ready and partially functioning, even if it doesn't look very good, and then make it fully functional and visually polished later. By the end of this code lab, your tip calculator app will look like this. So it will look like this: the cost of service, how was the service, amazing, 20%, good, 18%, okay, 15%, round up on the tip. You'll be using these UI elements that are provided by Android. Edit text: for entering and editing text. Text view: to display text like service, question, and tip amount. Radio button: a selectable radio button for each tip option. Radio group: to to group the radio button options. Switch an on and off toggle for choosing whether to round up the tip or not. Create an empty activity project. To start, create a new Kotlin project in Android Studio using the empty activity template. Call the app tip time with a minimum API level of 19. The package name is com.example.tiptime. Click finish to create the app. So we're going to go ahead and create an app called Tip Time. And so it says click the empty activity. So I'm going to go ahead and go to my Android Studio and I'm going to go to new project. Then I'm going to go to empty activity. And then it wants us to name the thing. The project's going to be named Tip Time. So just, yeah, Tip Time. And let me go ahead and name that the tip. Tip. Alright. Alright, so it's gonna be called Tip Time. Alright, now call the app Tip Time and it's gonna automatically name the package called example.tip time. And then instead of using the layout editor, which you're already familiar with, you will build the layout of your application by modifying the XML that describes the UI. Learning how to understand and modify UI layouts using XML will be important for you as an Android developer. You will be looking at and editing the XML file that defines the UI layout for this app. XML stands for Extensible Markup Language, which is a way of describing data using a text based document. Because XML is extensible and very flexible, it's used for many different things, including defining the UI layout of Android apps. You may recall from earlier code labs that other resources like strings for your app are also defined in an XML file called strings.xml. The UI for an Android app is built as a containment hierarchy of components, widgets, and the on screen layouts of those components. Note those layouts are UI components themselves. You describe the view hierarchy of UI elements on the screen. For example, a constraint layout, the parent can contain buttons, text views, image views, or other views. The children. Remember, constraint layout is a subclass of view group. It allows you to position or size child views in a flexible manner. Containment hierarchy of an Android app. Note, the visible UI hierarchy is based on containment. One one component, one or more components inside of it. This is unrelated to the hierarchy of classes and subclasses that you learned earlier. The terms parent and child are sometimes used, but the context here is talking about parent views, view groups containing children views, which in turn can contain children views. So the view group is the parent, and then under the view group can also have a view group and views, and under the view group can also be views. Constraint layout. Uh, each UI element is represented by an XML element in the XML file. Each element starts and ends with a tag. Each tag starts with a caret and ends with a caret, just as you can set attributes on UI elements using the layout editor design. The XML element can have attributes too. Simplified, the XML for the UI element above might be something like this. Let's look at a real example. Open activity underscore main XML. You might notice that the apps shows a text view with Hello World within a constraint layout, as you have seen in previous projects created from this template. Find the options for code split and design views in the upper right of the layout editor. Select code view. This is what the XML in activity main.xml looks like. There's a lot more going on than in the simplified example, but Android Studio does some things to help make the XML more readable, just as it does with your Kotlin code. So so you can inside the activity main XML, you might notice, so in here you can do the split view and select code. And so here, when you go to your Android Studio, and then you go to your layout here, you can do split view or code view, and then you see your visual there, and then the actual XML file is here. And so there is a lot more going on than in the simplified example, but Android Studio does some things to help make the XML more readable, just as it does with your Kotlin code. Notice the indentation. Android Studio does this automatically. Android Studio does this to automatically to show you the hierarchy of the elements. So, okay, so this is within the constraint layout there. So notice it says text view is intended because it is contained in constraint layout. The constraint layout is the parent, and the text view is the child. The attributes for each element are indented to show that they're part of that element. Notice the color coding. Some things are in blue, some are in green, and so on. Similar parts of the file are drawn in the same color to help you match them up. In particular, notice that Android Studio draws the start and end of tags of elements in the same color. Note the colors used in the code lab may not match what you see in Android Studio. XML tags, elements, and attributes. Here's a simplified version of the text view element so you can look at some of the important parts. In the line with text view is the start of the tag, and the line with the end right there is the end of the tag. The line with the Android text equals hello world is an attribute tag. It represents text that will be displayed by the text view. These three lines are commonly used shorthand called an empty element tag. It would mean the same thing if you wrote it with a separate start tag and end tag like this. It's also common with an empty element tag to write in on a few lines as possible and combine the end of the tag with the line before it. So you might see an empty element tag on two lines or even one line if it had no attributes. The constraint layout element is written separate with a separate start and end tag because it needs to be able to hold other elements inside it. Here's a simplified version of the constraint layout element with the text view element inside it. So, okay. If you wanted to add another view as a child of the constraint layout, like a button below the text view, it would go after the end of the text view tag and before the end tag of the constraint layout like this. So this has a text view and a button, and they're both, you know, child views for this constraint layout. More about XML for layouts. Look at the tag for the constraint layout and notice that it says Android X.constraint layout.widget.constraint layout instead of just constraint layout. Like the text view, this is because constraint layout is part of the Android Jetpack, which contains libraries of code which offers additional functionality on top of the core Android platform. Jetpack has useful functionality you can take advantage of to make building apps easier. You'll recognize this UI component and part of Jetpack because it starts with Android X. You may have noticed that the lines that begin with XML and S colon followed by Android app tools. Okay, so you see this also in your XML file in your Android Studio with the, let's go to the code view. Then you have the XML and S tools and app right here. And then you have the, you have this. And then and then XMLNS stands for XML namespace, and each line defines a schema or vocabulary for attributes related to those words. The Android namespace, for example, marks attributes that are defined by the Android system. All of the attributes in the layout XML begins with one of those namespaces. White space between XML elements doesn't change the meaning to a computer, but it can help make the XML easier for people to read. Android Studio will automatically add some white space and indenting for readability. You'll learn later how to have Android Studio make sure your XML follows coding styles conventions. 4. You can add comments to XML just like you would with Kotlin code. Start and end. Note the first line for the file. This indicates that the XML file. So we have this line. So this indicates that the file is an XML file, but not every XML file includes this. If there's a problem with the XML for your app, Android Studio will flag the problem by drawing the text in red. If you move the mouse over the red text, Android Studio will show more information about the problem. If the problem isn't obvious, look at the indenting and color coding, and they may give you a clue as to what is wrong. So, all right. So, this is how you add a comment to your XML file. You have to start it with this and end it with this. So we can go ahead and copy this just to demonstrate. And then, so inside our here, we can post this comment. So remember, inside the XML, you can't comment things like this. That will be incorrect. It will that's in your Kotlin code. That's how you can comment with that. But with commenting with this, you need this in front and this in behind it, and then that's how you comment in the XML file. Alrighty. So it says still in activity main.xml, switch to the split screen view to see the XML beside the design editor. The design editor allows you to preview your UI layout. It is up to personal preference which view you use, but for this collab, use the split view as you can see both the XML that you edit and the changes those edits make in the design editor. Try clicking on different lines, one below the constraint layout and then one below the text view, and notice that the corresponding view is selected in the design editor. The reverse works too. For example, if you click on the text view in the design editor, the corresponding XML is highlighted. So let's see, inside the Android, then when we go to split screen, so notice when we highlight the text view here, it will highlight it here as well so that you can see what text view is talking about. So even when I click it there, it will highlight it there. So it says delete the text view. You don't need the text view now, so delete it. Be sure to delete everything from the text view to the closing uh, bracket here. All that's left in the file is the constraint layout. The constraint layout. So let's go ahead and return to our text view, and then we're going to delete that. And then once we deleted that, it we just have our constraint layout here and a blank screen. So it says add 16 dp of padding to the constraint layout so the UI won't be crowded against the edge of the screen. So padding is similar to margins, but adds space to the inside of the constraint layout instead of adding space to the outside. So you can add 16 dp padding to the constraint layout itself. So let's go ahead and do that. So it's going to automatically have 16 dp padding around the borders. Some code snippets in this collab won't show everything for brevity. Code that hasn't changed or isn't relevant for the current step will be represented with ellipses, 3 consecutive dots, so you can focus on the most important parts of the code. Add cost of service text field. In this step, you'll add the UI element to allow the user to enter the cost of service into the app. You'll use an edit text element which lets a user enter or modify a text in an app. Look at the edit text documentation and examine the sample XML. Find a blank space between the opening and closing tags of the constraint layout. Copy and paste the XML from the documentation into that space in your layout in Android Studio. Your layout file should look like this. So we go to the edit text, and then it said we can copy this code from the directly from the edit text documentation. Let me actually go ahead and post the edit text documentation in the chat real quick so that newcomers can follow along. Edit the edit text field documentation above. Alright, and then we can go ahead and copy this code from our documentation here for the edit text, and says we can go ahead and paste it inside our constraint layout. Oops. And this actually needs to be at the end of our constraint layout. Alright, so this is the syntax for our constraint layout, the beginning and the end. And so in the end, I have to paste the edit text in there. Alright, so we have the edit text that has appeared in our layout here. You may not understand all this yet, but it will be explained in the following steps. Notice, edit text is underlined in red. Hover the pointer over it and you'll see a view is not constrained error, which should look familiar from earlier code labs. Recall the children of a constraint layout need constraints so the layout knows how to arrange them. Add these constraints to the edit text to anchor it to the top left of the parent. So we want to go ahead and add these two things to our edit text so that it will be to the top left of the parent. All right. So that's what we got so far. If you're writing in English or another language that's written left to right, the starting edge is the left, but some languages like Arabic are written right to left, so the starting edge is the right. That's why the constraints uses start so that it can start with either LTR or RTL languages. Similarly, constraints use in instead of right. Note, the name of the constraints follows the form layout underscore constraint source underscore to target of, where source refers to the current view, target refers to the edge of the target view that the current view is being constrained to, either the parent container or another view. With the new constraints added, edit text element looks like this. So layout underscore constraint start to start of parents. All right. Review the edit text attributes. Double double check all the edit text attributes that you pasted in to make sure it works for how it will be used in your app. Find the ID attribute, which is set to ID plain text input. Change the ID attribute to a more appropriate name, cost underscore of service. Note, a resource ID is a unique resource name of the element. When you add a view or other resource with the layout editor, Android Studio automatically assigns resource IDs for them. When you manually type out the XML, you need to explicitly declare the resource ID yourself. New view IDs in your XML file must be defined with the I plus ID prefix, which tells Android Studio to add the ID as a new resource. Choose descriptive names for resources so you know what they refer to, but they should be all in lower case letters, and multiple words should be separated with an underscore. When you refer to resource IDs in your app code, use R type name, for example, r.string.role for view IDs. For example, look at the layout height attribute. It's set to wrap content, which means the height will be as tall as the content inside it. That's okay because there will only be one line of text. Look at the layout with attribute. It's set to match parent, but you can't set match parent on a child of constraint layout. Furthermore, the text field doesn't need to be so wide. Set it to be fixed with 160 dp, which should be plenty for the user to enter the cost of the service. So they want it to be fixed with 160 dp, which should be plenty. Notice the input attribute, it's something new. The value attribute is text, which means the user can type in any text characters into the field on screen. Alphabetic character symbols. So let's see if we can go ahead and input the 160 dp for our width. So we go here to our edit text, and then can we say 160 dp, and then notice that input type. Do we have an input type? So input type. Okay, this is the input type. Input type is text, which means the user can type in any text characters into the field on screen, alphabetical character symbols, etc. However, you want them to only type numbers into the edit text because the field represents a monetary value. Erase the text, but leave the quotes. Start typing number in its place. After typing in, Android Studio shows a list of possible completions. Choose number decimal. So inside our Android Studio, we can type in numbered decimal, and that will only allow numbered items instead of text because it's the cost of service. To see other options for input types, specify the input method type. So here, I'm going to post this link for further, if anyone wants to further study here for specify the input method type. Reference link above. Alright. It says there's one more change to make because it's helpful to display some hint as to what the user should enter into the field. Add a hint attribute to the edit text describing what the user should enter in the field. So you will see the design editor update too. So we want to enter a hint where it will be grayed out. It won't be like the real text, but it'll be grayed out hint text. So we also add this to our XML inside our Android Studio. And then you see cost of service there. You will see the design editor update too. Run your app in the emulator and it should look like this. So let's go ahead and run our app in the emulator and it should look like that. Okay, great. There we go. So the cost of service is, oh, okay. So it allows us to enter numbers. All right. That's the beginnings of it. Alrighty. Says, nice job. It doesn't do much yet, but you've got a good start and have edited some XML. The XML for your layout should look like this. Add the service question. In this step, you'll add a text view for the question prompt. How was the service? Try typing this out without copy and pasting. The suggestion from Android Studio should help you. After the after the close of the edit text tag, add a new line and start typing text view. Select text view from the suggestions and Android will automatically add the layout width and the layout height attributes for the text view. Choose wrap content for both since you only need the text view to be as big as the text content inside it. So they want after the close of the edit text, add a new line and start typing text view. So we're gonna add a new line and start typing text view. So after the edit text, new line, start typing text view, and then it automatically populates it for you there. And but doesn't have the it doesn't have the end. But all right, so what does it want us to add there? So it wants us to do choose wrap parent for both since you only need the text view to be as big as the text content inside. So both of these are going to be wrap content. And then it wants us to add the text attribute with how was the service. And then notice the design editor that the text view overlaps the edit text. So it overlaps right now. That doesn't that doesn't look right. So you'll add the constraints on the text view next. Think about what constraints you need. Where should the text view be positioned? Horizontally and vertically. You can check the app screenshot to help you. So, okay. Vertically, you want the text view to be below the cost of service text field. Horizontally, you want the text field aligned to the starting edge of the parent. Add a horizontal constraint to the text view to constrain its starting edge to the starting edge of the parent. Add a vertical constraint to the text view to constrain to the top edge of the text view to the bottom edge of the cost of service view. Gotta change this ID to the correct ID. Alright. Awesome. So note that there is no plus in ID service because the ID is already defined. It doesn't look the best, but don't worry about that for now. You just want to make sure all the necessary places are on screen and functioning works. You'll fix how it looks in the following code labs. Add a resource ID on the text view. You'll need to refer to this view later as you add more views and constrain them to each other. So let's go ahead and make that one service underscore question. At this point, your XML should look like this. Cool. So So, all right. So, guys, we're going to continue the rest of this of tomorrow. So, stay tuned for part two of this lesson. And always stay coding. And you all have a wonderful day.